In the previous short, we showed the harmonic series diverges. We did this by grouping together terms and putting a lower bound on the sum of each group. But if we have any series of non-negative decreasing terms, we can generalize this argument. We ignored the first term. We said the second term was greater than or equal to the second term. The third term plus the fourth term was at least as big as 2 times the fourth term. The fifth, sixth, seventh, and eighth terms add up to at least 4 times the eighth term. And in general, we can take 2 to the n minus 1 times the 2 to the nth term and get a lower bound for the sum of that group. We can even fill in the first term divided by 2 in our first row to get this inequality to work for every single row. So the sum of an arbitrary series of decreasing non-negative reals is at least as big as the sum as n goes from 0 to infinity of 2 to the n minus 1 times a sub 2 to the n. Doubling both sides and rearranging, we see that the sum of this new condensed series that consists of every 2 to the nth term times 2 to the n is at most twice as big as our original series. Now let's change the grouping a bit. Let's begin each row with the 2 to the nth term as n ranges from 0 to infinity. Note that the first term in each row is the largest term in that row, so we can put an upper bound on the sum of the nth row of 2 to the n times that first term of the row, which is a sub 2 to the n. From this, we see that our original sum is less than or equal to the condensed sum. And earlier, we showed that this was less than or equal to twice the original sum. So we've sandwiched our condensed series between the original series and twice the original series. So if one of these quantities is finite, they all are. It follows that the original series converges if and only if the condensed series does. This is known as the Cauchy Condensation Test. Stay tuned for some awesome examples.